Okay, so in this video, you are going to solve this question I have on the screen. So the question says that a Zener diode is connected in a voltage regulator circuit. It is given that the voltage from the power supply is 20 volts, the Zener voltage is 10 volts, then the resistor from the input side is 220 ohms, and then the maximum power in the Zener diode is 400 milliwatts. So A, determine the values IL, IZ, and then II if RL is given to be 280 ohms. And then secondly, we should determine the value of RL, that will establish the maximum power in the Zener diode, which is what, 500 milliwatts. Okay, so that's the question on the screen here. So now let's go ahead and then tackle this question. So we have to find IL, IZ, and then I input here when RL is given to be 280. So first of all, we are going to look at the one that will be easy for us to find here. Okay, so when you look at this, you know that VZ is given to be equal to 10 volts. Okay, and then we've been given RL to be equal to 380. Okay, but you know that what the load and then the diode are connected in parallel. Okay, then the load and then the diode are connected in parallel, so that means that the same voltage will flow across through them. So that means the voltage in the Zener diode will be the same as the voltage in the load. So if the voltage in the Zener diode is given to be 10, that means the voltage in the load will also be what, 10 volts. Okay, so with this, let's go ahead. So you know that what, voltage equals current times resistance from Ohm's law. So we can make current the subject here. So that will be I will be equal to voltage about resistance. So in this case, we want to find I input. So that will be I input will be equal to the voltage. Sorry, that's the load current. Okay, the load current IL will be equal to the voltage about the resistance. So in this case, the voltage is 10 and then the resistance is what, 380. So let's see what we get for this value. So 10 divided by 380, so that gives me 0.0263 ampere. Okay, so that's the value of what, IL, which is the load current. So I can write my load current here, which is 0.0263 ampere. Okay, so now to find for the load current, let's look at the one that we can find easily again. Okay, so looking at the question, we've been given the resistance here. Okay, the resistance as this side, so that's Ri equals 222 ohms, and then you know current will be equal to what, the voltage about the resistance here. So in this case, the current is I input, and then the voltage we don't know yet. The resistance is what, Ri, which is what, 222. So what we need is this voltage, which is the voltage across this resistor here. So how are you going to find the voltage across this resistor here? So we can do nodal analysis here. So there's one node here, there's one junction here also. So the voltage at this junction will be the voltage from the power supply, which is given to be 20 volts in this question, and then the voltage at this junction will be the voltage in the Zener diode, which is given to be what, to be 10. So if I want to find the voltage across the resistor, I can subtract the voltage here at this junction from the voltage here. So that will be 20 minus 10. So in this case, that will be 20 minus 10 divided by 222. So this will give me 10 over 222. So let's see the value of this. So 10 divided by 222. So that gives me a current value of 0.045 ampere. So this will therefore be the input current from the source. So the input current, which is I input equals 0.045 ampere. Okay, that's the input current. Okay, so now that you know the input current, you can find the current in the Zener diode very easily. Okay, using Kirchhoff's current law. Okay, so that's, you know that the current moving towards the node because the sound of the current moving away from the node. So in this case, you see that the input current is moving towards this node. Let me clear this. The input current is moving towards this node, but the Zener diode current is moving away. The load current is also moving away. So we see that what the current input or the input current will be equal to the current in the Zener diode plus the current in the load. Okay, so now we want to find the current in the Zener diode, so we can make it the subject. So I'm going to take this one to this side, so that will be I input minus what the load current should be equal to what IZ, but I'm going to swap them. Okay, so this will become IZ will be equal to what I input minus IL, the same thing. Okay, so now that we know this, we can find IZ easily. So IZ will be equal to I input, which is 0.045 ampere minus what the load current, which is what 0.0263 ampere. So what will be the value for this? So 0.045 minus 0.0263. So that gives me IZ to be equal to 0.0187 ampere. So that's the value for IZ. So IZ equals 0.0187 ampere. Okay, so that was for the first part of the question. So now that we know this, let's go ahead and solve for the second part. So you see that you should determine the value of what RL, which will establish a maximum power of what 400 milliwatt in the Zener diode. Okay, so what is really happening here is that power equals what current times voltage. Okay, but in this case we've been given that the power is what maximum, so that would be PZ mass. Okay, the formula for maximum power in the Zener diode is PZ mass equals what IZ mass. Okay, IZ mass times what voltage in the Zener diode, that's VZ. Okay, so now we've been given PZ mass and then we know VZ also, which is what 10 volts, so we can find IZ mass. So IZ mass, that's the maximum current in the Zener diode, will be equal to PZ mass. PZ mass in this case is what 400 milliwatts. Okay, so let's just make it 400. Okay, 400, and then divided by VZ, and then VZ is 10. Okay, VZ is 10. So let's see what that would be. So that would be 400 divided by 10. Okay, so that gave me IZ mass to be equal to what 40 milliampere. Okay, that's 40 milliampere. So let's change this into ampere. So that would be what 40 times 10 to the power minus 3. So that would be 0.04. So that's 0.04 ampere. Okay, that's 0.04 ampere. 0.04 ampere. So this will be the value of what IZ mass. Okay, so then write IZ mass here. So IZ mass is 0.04 ampere. Okay, so now let's continue. So now that you know IZ mass, you have to find what the value of what IL, which will cause the power to be at maximum. Okay, so what really happens here is that when the power in the Zener diode is maximum, that means what maximum current is flowing through the Zener diode. Okay, so let's go back to this current formula. You know that I input equals what IZ plus IL. Okay, so what actually happens here is that when the current in the Zener diode is maximum, then the current in the load will be at minimum. So if IZ here is at maximum, then the current in the load will be what minimum. Okay, and then this is because the current value doesn't change. Okay, so when this one reduces, when this one is high, this one must be small, so that when they add up we get the same value. That's what this means. And also the second equation is that I input equals what IZ minimum, okay, plus IL maximum. Okay, this is what you have here. So what this also means is that, so in this case, when the current in the Zener diode reduces, then the current in the load will increase, so that they will all sum up to give what the I input here. Okay, so when the current in the Zener diode is maximum, then the current in the load will be minimum, and then when the current in the Zener diode is minimum, then the current in the load will be maximum. So that's what you are going to apply here. Okay, so now looking at these two here, okay, the IL minimum and then IL max here, all this means is that when the load current is minimum, that means the resistance in the load is very high, and then when the load current is maximum, that means what, the resistance in the load is what, is very small. Okay, so now one thing you should know is that when the current in the diode is at its maximum, that means what, the load current is what, minimum, and what that means is that the resistance in the load is very high, so that is causing the load current to go to be minimum. Okay, so what you have been asked to find here is the maximum resistance value. Okay, that's the maximum load resistance value, because it says that what, we should find the RL value when the power in the Zener diode is at its maximum. Okay, so when the power in the Zener diode is maximum, that means what, the current in it is also maximum, and when bring it into this equation, since the current in the Zener diode is maximum, the current in the load what will be minimum, telling us that what, the resistance in the load is at is at its peak, so the resistance is therefore high there. So the resistance value that you are going to find will be very big, because the current value is what, very small. So you are going to use this formula here. Okay, you are going to use this formula here to find for what, the RL value. Okay, so let's look at how you are going to do that. Okay, so the RL value will be the value, that's the current value in the load. Okay, when the will be the maximum resistance value here. Okay, so that's voltage equals what, current times what, resistance. So resistance will be equal to what, voltage over what, current. Okay, but you know that the voltage here is VL, and then the current here will be the, that will be the minimum current. Okay, that will be IL minimum. Okay, because when current is minimum, then the resistance value ought to be very high. Okay, so that's what it means. Okay, so now how do you find the IL minimum here? Okay, so you can use this formula here. So you know the I input to be 0.045. Okay, the current from the source doesn't change. Okay, since the resistor here is also constant, it doesn't change. So I input will also be the same as what I input. That it doesn't change. So that will be 0.045 will be equal to what, IZ mass. You know IZ mass to be 0.04. So that will be 0.04 plus IL minimum. Okay, so that's what we have now. So now from here we can make IL minimum the subject. So you know that we can take this one to this side here. So that will be 0.045 minus 0.04. This will be equal to what, IL minimum. Okay, so this will give me my IL minimum to be equal to 0.045 minus 0.04. That be equal to 0.005. So that's the value for its IL minimum. Okay, so now that you know IL minimum, you can go ahead and then come and find for the value of what, the RL that you've been asked to find. Okay, so now let's go ahead. So I'll go ahead and then clean this side here. Okay, so you have RL to be equal to what, VZ, which is the same as what, VL. Okay, which is the same as the voltage in the load. So that be, then make it VL. Okay, divided by IL. Okay, so now in this case, you know VL to be the same as the VZ, which is the same as the voltage in the Zener diode. So that will be 10 divided by what, IL, which is in this case IL minimum. So that will be divided by 0.005. So let's see what we get for this. So 10 divided by 0.005, that gives me 2000. So that gives me the value of what, 2000 ohms. So that will be the value of RL.